Okay, let's talk about what I'm calling section 3.3.5, which is just a refresher video or lesson over factoring quadratics. So this is something you spend a lot of time on in Algebra 1. I think it shows up in geometry as well. It's going to be useful in section 4, but we're going to take a day to revisit it, re-explain it, just so it's fresh in your mind. Do a few problems for you to practice, okay? So what I'd like to start off with here is just recalling the distributive property. The distributive property is the property that says that you can take something like 3x and multiply it here and here, right? And so what you end up with, in fact, let's zoom in a little bit here. So what you'll end up with is 6x squared minus 36x. Okay? And what I want you to take away from this is that these are equivalent expressions. In other words, if I gave you just this, you should be able to work back to that. Okay, the 3x times 2x minus 12. Okay, so that's in fact what factoring means. It's really undistributing. Okay, so for this one, when we use the distributive property, there's two ways to do this. There's what you probably heard of as the FOIL method, where you do the first times the first, the outside times the outside, the inside terms, and then the last terms. That is okay. I'm going to show you the box method real quick because this method will scale to harder problems and keeps your work more organized. You don't have to use this method if you don't want to, but I'll show you how it works. So if I take 2x and 3 like this, and x and negative 4 like this, all I have to do is multiply rows by columns. So I'll take 2x times x, that's 2x squared. 3 times x, that's 3x. 2x times negative 4, that's negative 8x. And 3 times negative 4, which is negative 12. And then I just combine like terms. So I have 2x squared, that's the only x squared term. I have 3x and negative 8x, that's minus 5x. And then negative 12 is its own term, only constant term. So again, what I should be able to do eventually is go either this direction, which would be distributing, or go from here back to the factored form, the undistributed form. All right. So that's what we're going to be focusing on today is factoring. Let's factor this expression here. In order to factor this, what I'm going to do is look for the lowest or the greatest common factor of 4 and 8. You can use your factoring sheet if you want to, but it looks like 4 is the greatest common factor of 4 that lines up with 8 as well. In other words, you can divide a 4 out of each term. Okay, so then I check the variable and I look what's the highest power of x in each term. And it's x to the 1. There's an x to the 1 power here. There's an x squared in this term, but not here. So I'm going to divide out a 4 and an x. I'm going to undistribute, same as dividing out. And I'll be left with, so if I take 4x squared divided by 4x, I get just x. And so I'll have x. And then if I divide 4x out of 8x, I'll be left with just 2. Okay. Again, 8x divided by 4x is just 2. Because if you think about this, what did you do up here when you distributed? You multiplied through. So if you're undistributing, what is the undoing of multiplication? Well, it's division. So here, I can think of this as dividing out a 4x. What's 4x squared divided by 4x? It's just x. Leaves me with that. What's 8x divided by 4x? Well, leaves me with 2. Last thing I'll say, you can always redistribute to check your answer, right? So 4x times x gives you 4x squared. 4x times 2 gives you 8x, okay? All right, let's move on to number 2. Factor the following expression. Now, this is a trinomial, right? There's 3 terms. It's a quadratic, and that means the highest power of x is 2. And so to do that, we're going to use what you guys use in Algebra 1, which is called the magic x method. So I'm going to show you that method right now. I'm going to show it to you generally, and I will also show it to you for this example, but generally, here's what you're going to do. Remember that all quadratics take the form ax squared plus bx plus c, okay? So if my a is 1 here, well, actually, hold on a second. Ignore the example for now, okay? So a, b, and c are the numbers I'm going to be referencing in the magic x. The top of the magic x, a, c goes up there, a times c. The bottom of it is b, okay? Now, the left and the right-hand side are going to be the numbers, the factors, okay, that help us factor it. I don't have a good letter for those. They're just, let's just call them P and Q. All right. And each one of those has to be divided by A. Right? So this is the general format for the magic x. Let's actually apply it to a problem now. So the problem that we have here, AC, so that'd be 1 times 6. So that's just 6. B goes down here, so that's 5. All right. Now, how do we figure out the P and the Q? Because that's the important part. That's the rub here, is how do we figure out P and Q? And what we're looking for is factors of 6. Actually, hold on. There's a typo here. Change the typo. This should be minus 6. Okay. So this should be x squared plus 5x minus 6. Okay, so sorry. There should be negative 6 up there. All right. So the question is, what are numbers that multiply to give me negative 6 but combine to give me 5? All right. And so if I want to do that, then I'm going to make just a little list out here. Numbers that multiply to give me 6 are 6 and 1 and 2 and 3. Okay. So now which one of these combines to give me 5? Well, they both do, except that if I need to multiply to get a negative, I got to have a negative and a positive, or a positive and a negative. Negative 6 plus 1 is negative 5. That won't work. But a positive 6 and a negative 1, positive 6 minus 1 gives me a 5. So that works. So I'm going to go 6 here and negative 1 here. Okay. And so when I do that, the last step is divide by a, but a is just 1. So I divide by 1 and I divide by 1 and I just get 6 and 1. So my result then is x plus 6 and x minus 1. So again, I'm taking these numbers here. So 6 goes here and negative 1 goes here, and that's my factored form. And if you were to FOIL this back out, if you were to multiply it back out, you'd get back to x squared plus 5x minus 6. Okay. The next few will go a little bit quicker because I don't need to write this part out every time. All right, so let's go to the next one. I'm going to set up the magic x. In the top goes a times c, so that's 1 times 12, so that's just positive 12. In the bottom goes b. So I'm going to look for factors that multiply to give me 12, but combine to give me negative 8. So factors of 12, 12 and 1, well, that won't combine to give me negative 8 in any way. How about 6 and 2? 6 and 2. 6 and 2, that could combine to give me negative 8 if they were both negative. So I think that works. So I'll take negative 6, and I'll take negative 2, and then the last step in the x is to divide by a. Well, a is just 1, so divide by 1 doesn't change anything. So these are my factors then. This is my right here and here. Okay, so let's write that out. This then will break into x minus 6 and x minus 2. Okay, and that's our final answer. And again, you could FOIL these back out, and you will find that you will get back to x squared minus 8 plus 12. Okay. You should pause this and try the next one. Although the next one, it does add a wrinkle into it, but you might pause it, try it, and see how it goes. So let's set up the magic x here. In fact, let's go. Okay, so a times c. Now a is not 1 anymore, so we're going to have to think a little bit harder here as we go. But 3 times negative 4 is negative 12. And then below, we're going to put 11. So now we're going to look for factors of 12 that combine to give me 11. So 12 and 1 are a possibility. And in fact, I think that works. So if I go negative 1 and positive 12, when I add those together, I will get positive 11. So I think I want 12 and negative 1. Now I'm going to divide by a, and this one, the dividing by a is actually important because a is not just 1. So I'll divide by 3. This one I will get negative 1/3, and this one here I will get 4. I should have given myself some more space, sorry. So these are the numbers that I'm going to put into the factors. Okay. So I've got x plus 4 and x minus 1/3. Red alert! We do not want any fractions in the factors, okay? This is not, I don't know what you would call maybe like standard form, or the bottom line is you don't want fractions in your factors. So what we do to solve that is we just take whatever the denominator is and kick it out in front. If you want to know why that works, then I'd be happy to explain it to you, but it's not necessary for this video. 3x minus 1. So there's your final answer. Okay. All right, let's move on and do another one here. So factor the following expression. Again, I'm setting up the magic x. I am predicting that since a is not 1, I'm going to need some space here. So a times c, it's negative 18. Again, you should give this a try first. See how you do. All right, so I got negative 18, and then b is 7. And then I'm looking for numbers that multiply to give me 18 and combine to give me 7. So I've got 18 and 1. I think that's going to work. How about 9 and 2? Oh, that could work. Let's check. I need a negative and a positive to give me a negative 18. So if we go positive 9 and negative 2, that should work. So we'll go 9 and negative 2. Now we have to divide by a. A is 6. Okay, so if I divide by 6 here and 6 here, and then simplify, 9 over 6 is 3 over 2. 2 over 6 is negative 1/3. And those are the numbers that I'm going to put into the factors. So I've got this, x plus 3 over 2 and x minus 1/3. Red alert! Can't have fractions. Okay, so I just move the 2 out in front and I move the 3 out in front. Okay, so I get 2x plus 3 and 3x minus 1. Okay, so that's my final answer right there. All right, last one. You should give this one a try as well. Pause the video and then play it through and see how it goes. This one is different. There's no middle term. There's no linear term. So let's see if the magic x still works here. So I'm going to draw an x out. A times c. So a is 1, c is negative 4, so I get negative 4. What is b? Well, it's got to be 0 because there's no linear term there. So it's just as if there was a 0x that we just didn't write down. So 0 goes here. So I'm looking for numbers that multiply to give me negative 4 and combine to give me 0. Let's check. 4 and 1. Nope. How about 2 and 2? Yeah, that'll work. If I make one of those negative and the other positive, then yeah, I combine them, so I add them. Negative 2 plus 2 is 0. So I'll put a negative 2 here and a 2 here. It doesn't matter which side. Divide by a. A is 1, so there's nothing to change there. These are my factors. So this ends up being x plus 2 and x minus 2. Okay, so the magic x even scales to problems like that where there's no linear term. All right, so that's it for factoring quadratics. Hopefully that brought back all of that stuff from Algebra 1 and geometry, and that's it. We should be ready to go on to section 4 once you complete the assignment that goes along with this lesson.